Welcome all. Uh, Today we'll be solving ODE from year 2023. So like it comprises around 6 questions in total, um, in different sections like question fifth, which is a compulsory question which comprises around 2 questions, and other 4 question in optional type questions. So we'll be starting from the first one. Uh, First one, which is basically about error function. So this is error function. Like how we define error function is that like error function of x is defined as 2 by root pi integration of 0 to x e की power minus t square dt. Like with respect to some function t, we are integrating e raised to the power minus t square, and the limit of integration starts from 0 to x. So this is the function. This was the main thing that we need to know in order to come to the final solution. So let's begin the problem. So the given is the initial value problem. Initial value problem is d2y upon dx, sorry, dy by dx upon 2xy2. So basically, we'll be solving this using integrating factor. The integrating factor is supposed to be like e की power minus 2x dx. So it basically becomes e की power minus x square. So putting into the format that has been given, like in the standard format of integrating factor, we put it as e की power minus x square to e की power minus x square integration. So this is the final solution, but we have been given limits. So putting those limits in here. So the initial limits is given to as initial limit is y equals to 1 at x equals to 0. So putting it here. So y equals to 0 at equals to 0 and y equal to at general x. So at putting here on the RHS, x equals to 0, x equals to at general x. So integrating it, we will be getting like this: y is equals to e की power minus x square minus initially at y equals to 0, sorry, x equals to 0, x equals to 0, y is equals to 1, and x equals to 0. So basically this becomes like this. So fine. So here on simplifying all these things. So we try to convert this part into error function part. Like what we do is like multiplying root pi in numerator and denominator. It becomes like this. So x e की power minus x square dx. So what it becomes is like that. This is error function of x. Y is equals to minus x square root pi error function of x plus 1. So taking e की power minus x square to the RHS side, this becomes as e की power x square plus 1 plus root pi e की power error function of x dx. So this is the final solution that we need to obtain, and hence we got the answer. Fine. This we like this we had to show, and we have shown this. So this is a problem from Laplace transform. So basically, the given here is that Laplace function of f of t is capital F of p. So simplifying it like from the definition we know that f of p will be e ki power integration from 0 to infinite e ki power minus pt, where p is a general constant. This p is variable in the Laplace integration f of t dt. So this is the one that we have got from the standard format of standard definition. Fine. So we have to show that f of x dx is equals integration from 0 to infinite is equals to small f of t dt. Fine. So we know f of from 1, like call it as 1, from we know from 1 f of x is equals to, just replacing p with respect to x, we are substituting 1 here. So 0 to infinite limits e raised to the power minus xt, just we are replacing p with respect to x, p with x, f of t dt. So like we have to show this thing. So since we try to make LHS format and we'll try to get RHS one, so f of x dx 0 to infinite, it becomes like 0 to infinite, like in place of, we are just keeping this part here. So putting this thing in bracket, 0 to infinite e ki power minus xt f of t dt dx. So now we have to integrate the whole thing, 0 to infinite f of dx. Fine. Now let's what we need to do that, like first we need to integrate with respect to x. So what is there, like with respect to x, t is a constant. So like here we can simplify this wala part here as 0 to infinite f of t. Since t and x are independent, so we can separate these two integration also. So we are separating these two, 0 to infinite e ki power minus x e ki power minus xt fine. So like this is something like this. So 0 to infinite f of t dt. So what it becomes like e ki power minus xt minus t, integrating from limits 0 to infinite, what it becomes like 0 to infinite f of x dx. Just we need to simplify the things. So if we put the limits here, it will become 1 by t, 0 to infinite f of t dt 1 by t. Like if we will solve it at infinite, it will become 0, and at 0, since it will become 1, minus plus 1, so it will entirely becomes 1 by t. So finally we had what we need to prove. So this was a thing that we need to told, that was told to prove. So hence proved. So coming to the second part. Second part was that it was given that we need to evaluate this integral. So if we compare the whole thing with this one, so we say that like f of t would be e की power minus e raised to the power minus t e की power minus e की power raised to e raised to the power minus 3t. So so what we do here that we do Laplace transform of f of t. So Laplace transform of f of t, Laplace transform of e की power minus t minus e की power minus 3t. So from the standard formula we can write it here as this application of formula here, nothing new sort of thing. Laplace transform of f of t, it becomes like that. So from formula we can say that we got and we know that Laplace transform of f of t is equals to capital F of p from the definition that we have got from this wala definition. Fine. So what we need to do, like we were given with this format, and we can convert this format into RHS1 from the given inequality, from the given equation that we have proved previously from this one. So we have f of p, capital F of p, which is nothing but Laplace transform of small f f of t, small f t, f of t. So capital F of x would be just replacing p with respect to x, x plus 1 minus x plus 3. So here we would through one the proven inequality equality, we can say that f of x would be d of x integration from 0 to infinite would be f of t, this wala term, this term from t dt 0 to infinite. So in order to find this, we can calculate this thing LHS1. So LHS is equals to 0 to infinite, 0 raised to 0 from limit 0 to infinite. F of x is given as from this wala term 1 by x plus 1, 1 by x plus 1, 1 by x plus 3 integration with respect to x. So the things becomes simple. On simplifying, it becomes 1 over ln x plus 1 ln x plus 3 by ln x plus 3 on putting the limits 0 to infinite. So taking the limits, like at infinite, numerator will be tending to infinite, denominator will also be tending to infinite. So taking the limits, so at infinite this will become 1 minus at 0 it will become 1 by 3. So this becomes ln 1 equals to 0. So ln minus of ln 1 by 3 becomes ln 3 from standard definitions of logarithms. So this is the final answer we have. Fine. So we have solved two questions. Coming to the third question. So this is a very standard format, standard question of differential equation. So the simple method to solve this is that put d2 dy by dx as d. Just simplifying. This is a standard ODE equation. In order to solve this, we break this such type of equation into format, like the homogeneous format. Homogeneous format basically f of x equals to 0, where RHS is 0, and particular solution. Homogeneous solution will yield us a complementary solution. Complementary solution and complementary solution, and then after finding the complementary solution, we will be finding the particular solution. So let's concentrate on finding the complementary solution. So putting in from the equation 1, from 1, putting the RHS equals to 0, we find we find the homogeneous equations, like something like this: dq dx cube minus 3 d2y dx square plus 4 dy by dx plus minus 2y minus 2y equals to 0. So we have assumed that d over dx equals to capital D. So it becomes d cube minus 3d square plus 4d minus 2 equals to 0. So from the in order to find the complementary solution, what we need to do is that just to factorize these terms. So finding complementary function, so it becomes like d cube minus 3d square plus 4d minus 2 equals to 0. So we have to factor this. So what we can do is that, like many times plus minus ones comes out to be solution. So it happens like in these kind of problems, many times plus or minus ones seems to be solution generally. So if you put 1, so it becomes 1 4 5 plus 5, and this becomes minus 3 minus 2 minus 5. So 1 is solution. So factorizing this, since 1 is solution, we can write it as d minus 1, and on, and putting the factors such that the whole equation becomes the above equation. So we factor it as d square. So if we put d square, then d cube minus d square minus 2d square minus 2d square minus d square minus 3d square plus 2d. If we put 2d, then it becomes 2d 4d minus 2d, then it's fine. Okay, simplifying this, since it will have imaginary solution, so we'll be using Sridharacharya quadratic equation basically. Solutions are d equals to 1 and d equals to minus b plus minus b square minus upon minus b plus minus b square minus 4ac by 2a. So d is equals to 1 and d is equals to 1 plus minus 4 minus 8, it should be b square minus 4ac. So it becomes 4 iota something like this. 4 comes out to be 2, then 2 divided by 2, it becomes 1. Fine. So writing the complementary function, the complementary y CF is equals to, from the standard definitions, we have already learned that complementary function is written as y is equals to c1 e की power x, y is equal to c2. Sorry, since this solution is imaginary, we will be writing this as e की power x c2 sin x cos x, sin x c3 cos x. How we wrote this if we do not understand, just then you need to go to theory part and try to comprehend from there, like if the solutions roots are imaginary and real, we have standard definition that comes in theory. You can go there from any standard book, you can refer there and see how we comes to this part. So this is complementary function. Now finding the particular solution. So if we write y is equals to, we have been given in RHS as e की power x plus cos x, fine, and the whole terms in capital D was dq minus 3d square plus 4d minus 2, I guess, minus 2. So we separated individually, dq minus 3d square 4d minus 2 plus cos x 3d minus 3d square 4d minus 2, fine. So in order to solve the particular solution of terms like e की power x f of x, what we do is that, like, whatever the coefficient of x, we tend to put here, but you will realize that if we put 1, it becomes 0. So 1 minus 3, 4 minus 2 plus 5 minus 5, so it becomes 0. So you might have read that in order to solve such kind of problem, what we do is that we put x e की power x and just differentiate denominator and again put the coefficients, say here, fine. If f of a is equals to 0, then we proceed like this. So similarly we try to solve for this part. So y particular is equals to x e की power x. If you put 3d square, differentiating we are the denominator part, 6d plus 4, fine. If you put 1 in denominator, it will become yp is equals to x e की power x, 7 minus 6, 1, fine. So this part becomes first part we solved, part 1. Sorry. Coming to the second part. Y particular is equals to cos x dq minus 3d square plus 4d minus 2, fine. So in order to solve cos function, what we do is that, like, d square is equals to I think d square is equals to minus a square, where a is nothing but the coefficient of x here. Yeah, fine. So d square becomes d square is equals to minus 1, fine. So yp is equals to cos x. We can dq can be factorized as d into d square, becomes minus d. dq is equals to d square is equals to minus 1 d. This becomes plus 3 4d minus 2 cos x 1 minus 1 minus 1 plus 3d. So we try to rationalize by multiplying the numerator denominator as 1 from 1 minus 3d, 1 plus 3d. Fine. We take a new page. Yp is equal to this cos x. What we get here is that 1 minus, sorry, we are correct now. Fine. 1 3d. So 1 minus 3d, 1 minus 9d square cos x. We put d square as minus 1, so it becomes minus 1 into minus 9, 10, 1 by 10 cos x minus 3 d cos x, 1 by 10 cos x minus 3 cos x differentiation d, specifically dy by dx. D is equals to d by dx. So it becomes differentiation. Cos x differentiation is basically sin x. Fine. So this was part 2. Combining part 1 and part 2, y total is equals to e की power x e raised to the power x plus 1 by 10 cos x plus 3 sin x. Now complete solution y, complete solution of yc complementary y particular. So y is equals to I think it was, yeah, c1 e की power x plus c plus e की power x c2 sin x plus c3 cos x x e की power x 1 by 10 cos x 3 sin x. So we get the complete solution answer. So we will be solving this one.